Hi everyone, in this video we are going to discuss the class test that we just did. So yeah, I hope that, from the process itself, you will be able to get an first-hand experience of how an online exam will look like, because looking at the current COVID situation, right? So most likely our semester exam is going to be online as well. So that's why, I hope that I give you an opportunity to experience how is that going to look like, how the devices work, then how is the whole process that you put everything together. So hopefully that can give you a better idea and can perform better in the real exams. All right, so yeah. Okay, so I'll try to go through question by question. So if let's say when you try to go through a video and you realize there's any question that you wish to ask me personally, feel free to just join in the meeting room and then just ask. Alright, so let's start with question one. So the diagram below shows a graph. So state the state the degree of the vertex C. Okay, so the degree, which means is how many number of edges that is incident, that is adjacent to the vertex C. So that's why in this case you can see there's 1, 2, 3, and remember loop is like counted as 2. So 1, 2, 3, 4, 5. So degree of vertex C is basically equal to 5. Okay, so it doesn't need to write this. As long as you mention 5, then you can mark yourself for the 1 mark. Alright, so remember to mark yourself and calculate the marks by yourself. Okay, B, determine with reason if this graph is a simple graph. So we know that a graph is only known as a simple graph if, let's say, there's no way, there's no direction, and then there's no loop and no multiple edges. So in this case, you can see that there's a loop at C. So that's why the answer is no. Alright, so how can you answer that? Because there is a loop at vertex C. Okay, so as simple as that. So make sure that whenever you try to describe something in graph and theory, right, try to write down in detail. So which means that if you were to write that that is a loop, then please write down where is the loop. Okay, so that you give your answer in every single detail. So because if you say that's a loop, how am I going to know that whether you understand whether what is a loop? Okay, so how do you need to prove that is from telling me where is the loop. Okay, so there's a loop at vertex C. Okay, so now part C. So for this question, 2 marks. So 1 marks for no. Alright, so this is 5. So 1 marks for mention no, because the question asks whether it's a simple graph or not. Then 1 mark if you mention a loop at vertex C. Okay, so C, verify that Euler's rule works for this graph. So you can see that there's no intersection between the edges. Out of the location where there's no intersection of edges for where except the vertices part. Yeah, okay. So C, verify the Euler's rule works. So that's why Euler's rule should work. So remember, when you try to verify or when you try to use Euler's rule to prove, so you must make sure that you're writing down everything. Okay, so B, we started with the vertices. So how many vertices that we have? So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's why there's 8 vertices. Alright, then after that, how many edges that we have? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so in this case, we have 12 edges. So the faces, the region, so 1, 2, 3, 4, 5, and remember outside. Okay, so that's 6 faces. So after you have state everything, then only you try to verify. So we are doing it by V plus F minus E. So which means in this case, we have 8 as the vertices, then after that plus 6 and then minus 12. Okay, so make sure you written down everything in full, then only you can maybe write down some working, 14 minus 12, and this is how you get to. Okay, so this is how you prove it. Alright, so the idea is make sure you need to state everything. So after you state everything, then after that you are using your formula to prove everything, so you can get the other second mark. Okay, All right. So please make sure that you are not doing like F plus. Okay. So with your habit in mathematics, right, I foresee that some students will do this. V plus F minus E equals to 2. And then you tell me here that 8 plus 6 minus 12 is equal to 2. Okay, whoever that did this again for your future exam, right, I'm not going to give any mark because I said already, this question asks you to prove Euler's rule to verify that Euler's rule work. So if you are starting with this formula, then which means that you already, you already denote or you already assign that you are going to get to after you do the working. But the idea is actually you need to prove that this part is equal to 2. So in mathematics, you can't actually write like this for any proving question. So make sure that you are stating everything down clearly. Then after that, you are doing the working of V plus F minus E. And at the end, you show the answer of 2. So please do not write like this. Okay? Alright, so now D, determine with reason if this graph is traversable. Okay, so we know that traversable meaning that you can actually draw this graph with one pen off. So which means that without taking your pen off, then you should be able to draw the graph. So how do you know that whether a graph is traversable or not? Is by looking at whether it's a semi-Eulerian or it's a Eulerian. Am I right? Because either semi-Eulerian or Eulerian will allow you to actually pass through all the edge without repeating any of them. Okay, so in this case, then we are going to check that. So how can we check that? Is by looking at, so if you can remember, then you should know that for Eulerian graph, we can always check it by checking the vertices of, by checking the degree of all the vertices here. So we can see that for A, that's like 3, 1, 2, 3, right? The degree here, and D is 3, 1, 2, 3, 4, 5, that's 5. Yeah, so you will realize that there's actually more than 2 odd vertices already. So that's why in this case, you should know that the graph is not traversable. Because when you have more than 2 odd vertices, which means that it's not even semi-Eulerian. So if it's not semi-Eulerian, then it's not going to, you do not have a road that actually allows you to go through all the edges once without repeating any of them. So in this case, the answer is no, it's not traversable. Okay, so in this case, then you can say that it has more than 2 odd vertices. So for more detail, then you can try to write down, which is at, so where's the vertices that actually give you the odd degree. So in this case, we have D. So A, B, D, actually everything except F and H, right? Okay, A, B, C, D, E, G. A, B, C, D is D. A, B, oh, there's no E. A, B, C, E, and G. Alright, so that's how you write down your answer. So 1, 2, 3, 4, 5, 6. What? That's a D. Sorry, I left out. Yeah, it's okay if you are not following the sequence, that's totally fine. But then it will be better if, let's say, you can try to put everything, as neat as you can, right? Okay, so A, B, C, D, E, and G. Yeah, they are all in odd vertices, odd degree. Alright, or you can write down that there are more than 2 vertices with odd degree. It's the same thing when you write down it has more than 2 odd vertices. Okay, let me repeat again. It's the same thing when you write it has it has more than 2 vertices with odd degree, or when you write down it has more than 2 odd vertices. They are basically the same. Alright, so by stating no, you will get 1 mark. By writing down your justification, you can get your 2nd mark. Okay, so E, I think this is an easy one. So just to identify a homogeneous cycle, so make sure that you are giving me a road, a walk, that you passes through all the vertices here without repeating any of them, and you need to end at the same place where you start. Okay, so in this case, I'm just going to write down one of my example answer here. So I'll go through A, B, F, E, H, G, C, D, A. Okay, so in this case, the thing that I try to go through is A, B, F, E, H, G, C, D, A. Okay, so then I passes through all the vertices, then without repeating any of them, I start at end at A. Okay, so how to check it? Then you should check 1, 2, 3, 4, 5, 6, 7, 8. So you should have 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry, back to 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, okay. So you should have 9 vertices that involve here. All right, because you need to repeat the one that you start, right? So that's why start and end at the same vertex. Okay, so this is how you check. All right, so passes through all, pass through all. Okay, so by having this, then you have your answer, 2 marks here. So when you are able to passing through every vertices without repeating any of them, you can get 1 mark. Start and end at the same vertex, you can get your second mark. Okay, so that's basically for question 1. So now let's move on for question 2. Alright, question 2. Below is a graph. Identify and state an Eulerian trail. Okay, so we'll start with checking the degree of the vertices. So if let's say there's like 2 odd vertices, then that should be where you start and where you end. So in this case, you will realize that it's the vertices of K and then E is having like the odd vertices. So that's why your Eulerian trail should start at K or E, then end at the other one. Okay. So in this case, then let's try to find out a trail that allows you to go through all the edges without repeating any of them. So the easiest way is to start with K. I think everything will seems like easier to go in this way, because obviously you can see that you can go from K to D, then from D you go to C, and then to B, A, E, and then go back to D, and then C, and then E. So you'll realize that the whole route here is basically going to be like K, E, K, D, C, B, A, then go to E, and then D, C, and then E. Okay, so this is how you get the whole route here. Alright, let me try to write my writing a little bit slightly better. Oops. Okay, so make sure that you are having a Eulerian trail, so you start and end at either K or E, then you'll get 1 mark there, then passing through all the edges. Okay, so 2 marks for this question. Okay, so now for part B, state the adjacency matrix M for this graph. Okay, so you realize that for this graph is kind of like a mix of non-directed and directed, so it's like a special cases here. But no worry, how are you going to do that? It's just like normally how you do that. So yeah, it's just like when I try to look at this, then you know that this is a one-way walk. So it's only allows you to travel from B to A. So where in the other hand, when you try to look at this, then you can travel from A to E, and you also can travel from E to A. So that's the only part lah. Okay, so let's try to write down the vertices that we have: A, B, C, D, E, and K. A, B, C, D, E, and K. Okay, so same thing for the column. Alright, so now we are going to fill in the detail. So let's start from A maybe. So for A, you can see that there's a walk that allows you to go from A to B, E only, so that's 1 here. So other than that, it's actually going in, right? So this is from B to A, so that's why you cannot indicate that there's a length of walk 1 from A to B. So that's why in this case, then the other entry is going to be all 0, because this is the only walk, that you can travel from A. Okay, then after that for B, then you can travel to A and you can travel to C. So that's why A and also C. So the other one all 0. Okay, I'll try to use this method so I can get a little bit faster. Okay, so for C, then you can see that this is going in, right? So this is not travel from. So the from part, then only you have from C to B and then to E. So to B and then to E. So other than that, it's all 0. Okay, then after that for D, then you can see that it can travel to C, and this is like multiple edges here. So D to C, so that's 2. Okay, then after that, D can also travel to E and K. So E and K, other than that, all 0. Okay, then after that, let's check out the E. So for E, you can travel to A, C, and also D. So A, C, and D. A, C, and D. So all the other one, all 0. All right, so now let's move on. The next one, we have the last one, K. So for K, yeah, it can only allow you to go to D. So that's why D to K to D. So other than that, all 0. Okay, so please check properly for all your entries here. Then after that, for C, calculate m squared, then you should be able to do this by using your calculator already. So I'm not going to repeat that. So yeah, it's basically your calculation. So I'm just going to fast forward this and to write down my answer. Alright, so please check every entry of your matrix, so make sure that everything is good. Okay, so D, use your answer in D to determine the number of connections between vertices K and C through the other vertex. Okay, so it's basically asking you about two paths, about a walk with length of 2. Okay, so I think that's clear. So basically, it's just like the connection between vertices K and C, right? So K and C, then you need to pass it through another vertex. So it's basically asking you about how many walks of length 2 that you have that connecting K and C together. So how can we check that? Then we know that the matrix of M squared is going to tell us the number of walks of length 2 between the vertices here. So that's why I'll try to check out between vertices K and C. So in this case, K and C is here. Okay, so you can try to check it out from C to K as well. So remember, if the question only write between vertices K and C, especially in this case because you are having a mixed graph, right? But in this case, it doesn't matter because for C to K, you are not allowed to go through that part as well. So for C, you actually can't go to K with a two-stage walk. So in this case, you are only allowed to do that from K to C. So you can just check from the cell K to C, then you'll realize that's 2. Okay, so in this case, that's 2. All right. So again, so please remember, it's just in this case that C and K is 0, so that's why it doesn't matter. But if let's say you're having the other one that allows you to travel from C to K, then you'll need to write that down as well. But you will need to always check, what is the identity of the graph itself, whether it's a simple graph or it's a or it's what is that called, directed graph, then you need to able to differentiate what do you need to do in the working. Okay, so in this case you have 2, then now let's try to check it from the graph because the question also wants us to name the connection. So from K to C. Okay, so K to C, so I think it's quite obvious. So 2 stage, so 1 2 and then 1 2. So both of the walks are KDC and KDC. So although they are the same thing, but they are actually different ages, so you will need to indicate both. Alright, so in this case, by mentioning two, then you'll be able to get 1 mark. Then after that, name all the connection here, then you are going to get each mark of it. So it's a 3 marks question. Alright, so just now, everything, yeah. So, I mean, this is like an exercise, so I hope that you take your initiative to actually check out everything. So make sure everything is correct, then you are given the 3 marks. So everything is correct, then you are given the 2 marks and such. Okay, so now let's move on to the next one. So vertices that cannot reach E with a two-stage walk. Okay, so in this case, same thing. So by how are you going to identify whether there's a walk of length 2 or not is by looking at the M square matrix. So that's why cannot reach E. So you are looking at from what to E. So that's why you are looking at this column. Okay, so because this column will tell you that how many number of walk of length 2 that enables you to travel from A to E, from B to E, from C to E, from D to E, from E to E, from K to E. So you'll realize that for this part, you will have this 0 and then this 0. So it indicates that there is 0 walk of length 2 that allows you to travel from vertex A to E and from vertex C to E. So that's why the vertices that cannot reach E with a two-stage walk is basically A and C. Okay, so yeah, I hope things is clear. Alright, it's different if let's say the question asks the other thing is vertices that cannot or what is the vertices that you cannot travel from E with a two-stage walk, then you will be looking at this part, because this part will tell you that what is the vertices that you cannot reach from E, okay, with a two-stage walk. Then that's why your answer will become A and D. So that's like totally different thing, because in this case there's direction involved. So that's why if you are able to travel from if you are not able to travel from A to E, it doesn't mean that you cannot travel from E to A. Okay, so in this case, each of the vertices will get you 1 mark. Alright, so that's question 2. So let's move on to 3. Okay, question 3. The weighted graph below shows a route network between several towns. So the distances are shown alongside the edges and also in the unit of km. So A, the question one is to find out the shortest path from A to M. So give this distance. So normally for the question for shortest path, right, then you will need to write down your working in a graph that is given. So I mean, in this case it's because of I prepare you another sheets of the answer script, so that's why you have like the extra picture here if let's say you want to use it. So for this part, so as what I mentioned in your answer script, the only thing that you are compulsory to write down everything in your graph is basically part A. Okay, so in this case then we are just going to find out the shortest path. So let's do that. So from A, so we start with 0 here. So now let's check it out. So the shortest distance to the adjacent vertices here, then you have 47, okay, which you pass through here. So 55 where you pass through here. So in this case, then we will need to do this first so that you can try to use it to see which one is the shortest one when you move on to E. So in this case, then you can see that for this part, it will already give you 86. So when you go through here, it's already give you a bigger number. So that's why the shortest one will be here, which is 75. Okay, so 75 plus 8, 55 plus 30, 47 plus 39. So the shortest one is actually here, which give you 83. Okay, sorry, I forgot this. Alright, so 83. So after you get 83, so now let's move on. So for this part to this part, you have only one, either you can do here to here or here to here lah. But obviously you can see that 75 plus these two number and 83 plus this number, obviously this one will give you a shorter one. So you can try to do this first. So this is 1, 2, 3 after you add them up, because you do not have other choice, right? So either you go through here or go through here. So obviously this is going to be shorter. So that's why 109 and you pass it through this. Okay, so until you get 109, so 10, 10, so it's the same thing, 119. So yeah, it's not impossible that you want to, it's impossible which you want to use this, right? So 119. So 29 and 30, so this one. Okay, So in this case, I'll get 119 plus 29, which gives me 148. So let's try to trace it back. So we have the ending at M, then after that we use L. So before L we have H, before H we have E, before E we have D, before D we have C, and then go back to A. Okay, so that's why your answer should be A, C, D, E, H, L, M. So with the distance of 148. Alright, so please make sure that all your calculation in the graph in your working must be shown clearly and accurately as well. So in this case, right, the 3 marks will be given for your answer, your shortest distance, and also the working that you try to do in a graph here. Okay, so now for part B. So find the shortest distance from A to M via E to K. So which means the question require us to actually go through E and K. So in this case, you'll realize that actually from what you have here for part A, right, you already go through E already. So the only thing that you doesn't have is actually K. Okay, so that's why, sorry, I think that's a mistake here. I'll try to change it for your exam. So this is E and K. Okay, yeah. So find the shortest when you get your question, you should be able to see via E and K. Okay, so which means that in your shortest path, the question one is to involve E and K. So E is already involved before, so that's why just by looking at this graph, then we can try to do that. So you actually doesn't need to redo everything. So by looking at this graph, I'll try to use the other color so to indicate that I'm doing the working for part B. So you realize that what you have here is you already go through this way, right? So that's why you are just going to go through the same thing. The only thing is when you reach H, you are going to go through K rather than go through L. So if let's say you are going through K, then which means that you are taking 30 instead of 29 here. So that's why only the difference here is instead of going through here, then you are going through here. Okay, I hope that you understand what I mean here. So that's why your answer here should be A, C, D, E, and then H, K, M. Alright, so in this case, you are passing through like here. So A, C, D, E, and H, so K, M. Okay, so just now in part A, you are doing this way. So now we are going here. Okay, so this question you doesn't really need to redo everything. So as what I said, the graphic is actually for your reference only if let's say you wish to redo. So the idea is the distance. Then you can see that the only difference here is actually just the 30 and 29 here. So that's why the distance here will be 1 extra, so which is 149. So in this case, you are getting your answer for identifying the path, the shortest path with K, then after that, the distance. Okay, so for C, so find the shortest distance starting from A and finishing at A, visiting each town at least one give this distance. So which means that you need to go through everything, then after that go back to A. So you realize that this thing is hard because when you try to go through everything, which means that you need to go to the end, then from the end, then you come back. So what is helpful for this question is we try to take into the consideration of the shortest path that we have found just now. So how can we do that? So you can write down first for your shortest path. So just now we go through here, so which is 0 and 55, 75, 83. Okay, and then we are taking here 109 and then here 119 and then 148. Okay, so which means that since you already know that you need to go to the end and after that come back, then let's try to check whether we can try to get the shortest path by doing that or not. Okay, so in this case, if let's say we are using the shortest path that we have, then it should be A, C, D, E, H, L, M. So that gives us 148, am I right? So after we get this, then now let's see how can we go back to A. Then after that, we want to pass through the edges, the vertices that we didn't pass through yet. So how can we do that? Then you come back at K lor. Okay, you get what I mean, right? So which means in this case, then you are going to do from M, then you are going back to K. Okay, let me try to do this, maybe you can understand better. So this is the route that we already take. Alright, So for the verses that we already passes through, you can, but the idea is you must make sure that you're visiting each town at least once. So which means in this case, when we are going back to the situation, then we are taking the vertices that we haven't passed through yet. So which means when I at M, then I want to go through here, then I go back here. Okay. So K, then I go to H. So just now I already passed through here, right? So now I will need to go to G. So that's why I'll go to here and then here. So that's why GD. Okay, so when I'm here, then I'll choose the easiest one that I can go back. So either because C you already passes through what, so that's why it's when you have a choice where you want to go CE or you want to go E, then obviously the shorter one is to go through the 8 here. Because your target here is to pass it through B because you already have your connection here. So that's why I'll choose to go back here. Okay, so that's why E and then BA. So this is how you get your walk. Okay, let me try to justify like why we are not using, why we are not trying to pass through everything when we go out. I mean when during your first journey from A to M, because you know that at the end you are still going to go back. So okay, you can imagine, right? If let's say I try to use okay, the pink color here. Okay, you imagine if let's say in your first journey you are going to pass through everything. So what will you end up with? So I'm just trying out. Okay, if let's say I go through here. Okay, I pass through everything, right? So here, then maybe I go through here. Okay, so what you realize here is you still need to go back, right? So when you go back, isn't it you are repeating the one that you already have? So that's why by doing the shortest path, then after that to check out what are the vertices that you did not do yet, will definitely going to help you in this case. Okay, so you need to decide how is that going to work by looking at your picture where you have like in this case is A to M, then you need to go back. So that's why you doesn't want to spend your time to double up. So that's why just by using your answer in A and C, then after that to write down your answer. So now let's try to do the calculation here. So 148 is the 2. Then when we come back, we have 30, 10, 40, 48, 8, 39, and 47. Okay, so in this case, this working is not important, but writing down everything clearly is important. All right, because this is your own draft only. So 148, 30, 10, 40, 48, 8, 39, 47, and you are going to get the answer of 370. Okay, so that's basically the idea. All right. Okay, so in this case, you'll be able to get your answer, I mean, your 3 marks if let's say you got everything correct here. So, I mean, if in the real exam, then maybe you'll get 1 mark if you get the route where you can pass through everything, then you start from A and back at A. But maybe your distance is not the shortest one, then maybe you can get 1 mark out of it. Alright, so that's basically for part 3, question 3. So now move on to question 4. Okay, question 4. So A, B, C, D, E, and F meet at a party and each shakes the other's hand. So if a graph that represents the handshakes between the 6 people is drawn, so name the type of graph that you have and justify your answer. Okay, so in this case, you can understand that when you are trying to connecting the vertices together, it means that when I try to draw A and B, that which means that A shakes hand with B. Okay, and when A shakes hand with B, then which means B shakes hand with A as well. Lor. So you can imagine that if everyone shakes the other's hand, then which means that in this term, after you draw everything out, then you should be able to get a complete graph. Okay, so if you are not sure with this, then you can try it out. So basically, you can understand where you have A, B, C, D, E, and F, right? So imagine everyone shakes the other hand, so which means that all the other, you will be connecting all the vertices. I mean, you will be, all your vertices here should be able to connect to all the other vertices by a single edge here. So which means B is going to shake hand with C, with uh, E, with F, with D as well. So after you actually draw everything, then you should be able to get a complete graph. Okay, you can try to draw it out by yourself, but I hope that you get what I mean. So in this case, you are not I mean, you do not really need to draw it. The idea is you need to understand that what you are doing here. So end up, you know that you are getting a complete graph. Okay, so a complete graph. So how do you justify your answer? So the idea is everyone shakes the other hand. Okay, then go back to the definition. So you know that all vertices are joined to every other vertices by an edge. Okay, so this is the idea. So make sure that the idea is you must mention that, I mean, it's connected to all the other vertices by an edge. So make sure that by an edge is important because that shows that you understand that it's not only connected, but they are all adjacent to each other. So that's why it's a complete graph. Okay, so answer and then your justification. Okay, so part B. Due to some disagreement, A, C, and E refuse to shake hands with each other, and similarly, B, D, F refuse to shake hands to each other. So draw a suitable graph to represent the handshakes between the 6 people here. Name the type of graph that you use and justify your choice of the graph. Okay, so which means in this case, you can see A, C, E, and then B, D, F. So obviously, the one that refuse to shake hands with each other is definitely going to be in one group. And if you can recall, then this basically go back to the idea when we talk about bipartite graph. So which means at one group you have ACE, and you know within the group they are not going to connected, or I mean they are not going to connecting to each other. Am I right? So that's why ACD is like one group, and they only shake hand with the other hand of people. So which is BDF. And similarly, BDF they didn't shake hands with each other as well. So that's why this will give you a bipartite graph. So in this case, then A shake hand with B, with D, with F. So the same thing here, you have B, D, F. Okay, and then B, D, F. And then between ACE and BDF, they refuse to shake their hands with each other. Make sure you are using your ruler. Yeah, sorry, my drawing is a little bit messy here because of, I mean, I'm not using any straight lines. Okay, so that's the idea. So the graph that you are having here, so to be complete, then your graph should be called as complete bipartite graph. Okay, so which means every vertices in one group, you can connect to the other part. So that's why it's called a complete bipartite graph. So justify your choice. So because the vertices can be split into two distinct groups. Okay, the second thing is, you know, the edge is going to connect the places from each group, right? So each edge connects one person, yeah, which means the vertex from one group to the other group. Alright, so that's basically the justification that you can give when you're using like bipartite. Okay, so in this case, then you are having like 2 marks for the graph, then you're mentioning this 1, 2 here, and then split it into two, then you understand that the edge in bipartite graph should be connecting like the vertex from one group to the other group. Okay, so that's question 4. Okay, so now let's move on to the last one. Alright, number 5. This is the adjacency given for a planar graph. So the graph is said to be a simple graph using the feature of the adjacency matrix justify this statement. Okay, so by looking at this thing, the first thing that you need to know is if let's say it's a simple graph, then which means that it's going to be symmetrical about the leading diagonal. Am I right? So when it is symmetrical, then you know that there's no direction. So that's the first thing. So you can write down. So the graph is symmetrical about the leading diagonal. So make sure that every time when you are trying to write down symmetrical or asymmetrical, make sure that you are writing down the leading diagonal. Okay, so symmetrical about the leading diagonal, so it actually means that it's not directed lah. Oh yeah, one more thing. So please remember that when it is symmetrical about the leading diagonal, right, it doesn't mean that it's a simple graph. It actually just means that it's a non-directed graph. Because the idea is that when you say it's a simple graph, which means it's non-directed, and then it has no loops and no multiple edges. So you can imagine that if let's say I have two here, right, it still gives you symmetrical about the leading diagonal. The difference is that there's two edges connecting B to A. So that's why in this case, then you are having a multiple edges. So it's still not a simple graph. I hope that you get what I mean, right? Okay, so that's the first thing. You prove that there's no direction. So the second feature is by looking at the leading diagonal. So I explained this before. So as long as you can see is all the zero entries in the leading diagonal, then it tell you that there's no loop. Am I right? So when everything here is zero, then you know that there's zero edges connecting A to A, zero edges B to B, zero edges C to C. So that's why zero entries in leading diagonal. So that tells you that there's no loop. Okay, so that's the second thing. So remember, you still have the last thing, which is proof that there's no multiple edges. So without these three, then only you can say that it's a simple graph. Okay, so now how do you know that whether there is a multiple edges or not? Is by looking at every entry that you have here is either 0 or 1. So the adjacency matrix tell us the walk of length 1. Am I right? So which means that if let's say every entry here you only have 0 and 1, which means that either that is no walk of length 1 or there's only one walk of length 1 that connect the vertices together. So that's why there is no edges. There's no multiple edges that connecting the same pair of vertices. Okay, so you can try to write down all the entries. Are 0 and 1. Okay, so which means that there's no or only one walk with length 1. Okay, between the vertices. Okay, so in this case, by looking at this picture, then you know that there is no multiple edges. So again, next application is about understanding. Make sure that you are understanding everything that you are doing, then that's going to be helpful for you. So each of these will give you 1 mark. Okay, so after that, move on to B. So draw a planar graph based on the adjacency matrix. Okay, so you will realize that for this graph, right, if you were to, okay, I'm going to draw a graph here, then you'll realize that it's actually not easy to draw a planar. So you have 6 vertices, so let's try to just do it like this: A, B, C, D, E, and F. Okay, so let's check it out. So you can see that for A is not adjacent to F. So that's why I can draw everything. Okay, for B is not adjacent to D. So that's why okay, so you can see it started to intersect already. Alright, so B to A, you are not going to draw it anymore because A and B to A is the same thing. This is a simple graph, right? Okay, it's a non-directed graph. Okay, C is not adjacent to E. So that's why. Okay, the other one have already. So D is not adjacent to B. So the other one. Okay, and for E is not adjacent to C. E is not adjacent to C. Okay, other all have already. F is not adjacent to A. So all the other 1, 2, 3, 4. Okay, so you realize that there's like quite a lot of number of edges that you will need to redraw. So in this case, you can see, right, if let's say I try to redraw this, then I try to put it outside. Okay, maybe I'll try to redraw B and E as well. Okay, now you'll realize that there's a problem here because you can't pull out any more edges, because no matter which one that you are trying to take it out is going to intersect with the one that we draw it outside. Am I right? So if you are taking out FD, then it's going to intersect here. If you are taking out AD, then I mean in this case definitely you can't take out a lot. I mean you pass it through both, right? Then after that, in this case, if you want to take out FC, then it's going to pass it through your this part, the edges here as well. So that's why you will need to redraw. I mean, try to restructure. How are you going to do that? So in this case, you realize that when you look at every single vertex here, right, there's only one vertex that is not adjacent to that particular. So for example, when I try to look at A, A is only not adjacent to F, and then B, so B is only not adjacent to D. We are not looking at this because this indicates the loop, right? That C is only not adjacent to E. So that's why in this case, then you know that for every vertex, that's going to be 1, 2, 3, 4, 4 edges that is incident to that particular vertices. So in this case, what we can try to do is we try to put that in the middle. So in this case, what I will try to do is I'll try to place my A in the middle. Okay, so just now we said that A is not adjacent to F, right? So that's why I'm just going to draw B, C, D, E outside. So B, okay, C, D, and also E. So now let's try to check whether it works or not. So we have A to C and A to B, A to E. Let me try to, okay, A to E and then A to D. Okay, so now let's check the other one. So for B is adjacent to everything except B, except D. So in this case, yeah, D is at this side. So that's why you need to pass it through. A only can reach D, right? So it satisfies what I want. So in this case, you see an F, then you can, I mean, draw anywhere that you want. So in this case, I'm just going to put it here. Okay, so B adjacent to everything except D here. So I'll try to draw it outside. Okay, then after that, continue for C. C is not adjacent to E. So C is not adjacent to E. So that's why my E is here. So you know that if let's say you are doing A, B, D, E just now, then you should be able to change their place, because you know that when you are trying to draw like this, then which means that C is only adjacent to A but not adjacent to E. Okay, so which means you might need to rearrange how you put down your vertices. Okay, so in this case, then you are trying to connecting the other. So same thing, let's check out D. So D is not adjacent to B. So that's why B is opposite. So in this case, I'm going to put it like this. Okay, then it's correct because D and B is not adjacent to each other, then the other one is all adjacent already. So now the E one is not adjacent to C. So E is not adjacent to C. So E is not adjacent to C, which is correct, but E is adjacent to F as well. All right, then the last one, F, so check, so it's adjacent to B, C, D, E. So that's why I have B, C, D, and E. So that's why this is correct. So whether this is a planar graph, yes, because there's no intersection of the edges outside of the place where you have your vertices. Alright, so I hope that you get the idea here. But yeah, this question is actually a little bit challenging where I need to spend time to actually think about it. Okay, so for C, I hope that you already can see the 3D shape here. So the thing that you are going to have is you can try to draw your square here first, or your, rectangle here. So BCED. BCED. Okay, so after you have this, then you'll realize that at this part is basically like A in the middle. So you can try to imagine that when you're trying to draw a 3D shape, it's going to be like this. Okay, and then you're connecting here, 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 and also here. Okay, Then after that, the other way, then the same thing, you'll realize that this is how A and F is not adjacent to each other because F is at the other side. So for the F here, it's going to be like downwards. So that's why in this case, then you have your F here. Okay, let me try to put another place that is easier to maybe here. Okay, so when you're drawing it, then it will be like this, dotted line. Okay, so here, then from B to C, that's one. Alright, so I hope that you can see the shape here, or if you are not doing this, then you can, yeah, basically that's the idea lah. Okay, or if you are drawing like see a little bit out, right, then the thing that you can have is like, but the idea is just the same lah, it's just, I mean, how you put your vertices is going to be a little bit different. This, so if you are doing here, that which means that you're going to do the solid line. Okay, but basically that's the shape that you should have. Or if you are drawing it, I mean left to right also can, but I think that's a little bit to show that it's a 3D shape. So make sure that you have your all your vertices connecting correctly, which is you can see that here they are all adjacent to A. So for all this, they are all adjacent to F. So this is how you get the answer here. Okay, so this is question 5. So you can have the other drawing which I mean in the same shape, but then maybe your vertices is in a different arrangement. That doesn't matter as well. Okay, so that's basically for answer for number 5. So let me know if let's say you have any question. Okay, that's basically the discussion part. Alright, so after you finish everything, remember to count your marks and to put in your reflection before you before you move on to your lunch break. Alright, so yeah, I'll see you on Thursday class. Alright, thank you. Oh yeah, it's going to be a pre-recorded one lah. So yeah, I mean see you in terms of pre-recorded video. Alright, so thanks.